Hi, this is Miss Litton, and this is my wonderful Period 2 Honors Biology class. Say hi. Hi. And we are discussing Chapter 13, the lymphatic system and immunity. Your immune system is very, very cool. The things that it can do. Your nervous system, obviously your brain, super important. Heart, super important. But your immune system, every single moment of every single day, is put to the task of deciding this is okay and this isn't okay. This cell is all right in my body, this cell isn't all right in my body. It can tell self from non-self. And whatever is non-self, it attacks. Does it attack everything you ever put? No. How does it know that jelly is okay, but for some people, peanut butter isn't, right? Do I have any peanut allergies in here? Okay, does anybody know somebody who has a peanut allergy? Look at how many of you raise your hand, okay? You know what they're saying now? They're saying that because peanuts weren't given as a young child, you used to be told don't give them too early. They think now that's why people have allergies, because you didn't learn to eat the peanuts. And that maybe we need to go the other extreme and start introducing peanuts earlier into our diet, and that's why people have been allergic to it. I'm not saying to go give peanuts to a child, but I'm telling you, for some people, if they have a peanut, it is literally, it could be deathly. They can have, does anybody know somebody who has a severe reaction? Yeah.
Yeah, my friend's younger brother has I guess there are 5 levels, and he's at the 5th level. My brother had a cookie that was made in a factory with peanuts, and he opened it, and he was right next to him, and he started breathing heavier and started turning red.
Yeah.
Just that.
And do you know Miss Fowler? Mrs. Fowler's sister, we would go scrapbooking together on weekends. Did I already tell you this story?
No.
So we would go, this house was made for scrapbooking. We used to go for the whole week. It was super fun, and they catered to you. It was really nice. But anyway, there could be peanut M&Ms sealed in a package in another room, and she would start to have a response to it. So how is it? Now, I love peanut butter. It's one of my 5 foods that I would take to my island if I could only pick 5 foods on my island. And I love peanut butter. How is it that in my body goes, peanuts are fine. And in everybody else here in this room, peanuts are fine. But to somebody else, they're like, oh my gosh, and starts attacking it. How many of you get allergies? Okay? Those of you that get allergies, and you can be allergic to one thing, or it seems like you're allergic to the world, and you have to take pills. Think about that. Every day you're coming in constant contact with different molecules, and some of you are going, oh, I can't handle it. You start developing a response to it, and others of you are just fine. So our body, think about how many different molecules it processes. Think about all the different foods that you eat, that you actually put in contact with the body or surface of skin. Think about lotions you use, ladies, and things like that, or hair products or makeup, and you're okay with it. You can see a little bit of that if any of you wear earrings and they make your ears itch, and they start to bother you, and by the end of the day you're like, oh, I need these out of my ears. Those are your T cells saying, I'm not comfortable with this metal that's in my body. And at that point you're trying to, if you just take that earring out of your ear, you'll do, thank you, sweetheart. If you take that earring out of your ear, you're already going to be okay, and they'll start to feel better. If any of you have, just a little tip though, if you have really cute earrings and they bother your ears by the end of the day, if you would just put a little Neosporin on them, or even chapstick before it goes on it, just rub some chapstick on that and then stick it in your ear, it won't bother you during the day. It just needs some little barrier between your skin and that metal. My sister, if she wears a belt like this, and if it's cheap metal, later when she undoes her pants, you would see an outline of the metal perfectly on her skin. And she's wearing a pair of jeans between herself and her belt. So everybody's different. But think of all the things you come in contact with. And your body goes, this is okay, and this is not okay. And for most of you, it's not a problem. Do any of you know somebody who has lupus? Okay. So is it just primarily in their joints or full body?
Just joints.
Yeah, so sometimes your body will attack just your joint areas, which is incredibly painful if you know somebody who has lupus. That incredibly painful where their joints are hurting so bad. But I have a girlfriend's daughter who has lupus, and it's where your immune system doesn't recognize your own tissues anymore, and you attack your lungs or you attack your kidneys. And the membrane that goes around your lungs is called the pleura. And for her, it would attack that, and fluid would build up between her membrane and her lungs so that she couldn't breathe. And I would visit her in Children's Hospital, and there's a tube coming out of her chest just draining all the fluid that's building up within her lung cavity. Or it would attack her kidneys. So we have issues, we can all have issues with our bodies, but for the most part, they work fairly phenomenally, you know? There are a few allergies here and there, and some that are, you have to really monitor. Bee allergies. How many of you know somebody who's allergic to bees? Okay, anybody in here allergic to bees? Okay, and so do you have to carry the shot?
No, just...
Yeah, you have to be careful.
Yeah.
Yeah, so, and what happens is some of our immune system cells have memories, so they remember it and they react even larger, you know, a bigger response to it. And that's where it can start. You could go into anaphylactic shock or some of those other things. But for the most part, we do pretty good with our immune system. So our immune system is sitting right next to our circulatory system, pretty much everywhere. If there's a blood vessel, there's a lymphatic vessel that's sitting right there. And you recall when we talked about that close association that our circulatory system has with it. Do you remember when we looked at a capillary bed, at the arterial end of the capillary bed, what pressure was really strong at the arterial end? Hydrostatic, perfect, hydrostatic. And that would force fluid out at the arterial end. But by the time the blood travels through the capillary bed, another pressure is greater, the pressure to come in. Do you remember the name of that pressure? Osmotic pressure. But you could have more fluid go out than comes in. And so you'll have this leftover fluid around your cells. Your lymphatic system will pick up that excess tissue fluid. And now you don't call it tissue fluid anymore. Once it's in your lymphatic system, it's now classified as lymph. And you'll take that lymphatic fluid, and you'll pass it through lymph nodes before you return it at your subclavian veins, right underneath your clavicle. You have these subclavian veins. You can see it in this picture up here in the top right. And so that fluid that was in your blood, then around your tissues, and now is in a lymphatic vessel, now gets returned to your circulatory system right here at the left and right subclavian veins. Now, before it goes through, like I said, it passes through lymph nodes. You have some in your throat. Feel your throat right here, and feel your lymph nodes there. Can you feel them? Is anybody sick?
I feel them.
You feel them? They'll get bigger when you're sick, and the reason is your lymph nodes. You have some here. You have some in your armpits. You have some really big ones. You have some along your back. You just can't feel those. You have some in your groin area where you have lymph nodes, and your immune system cells. They just have to hang out at the lymph node, because if something's in your body, it's going to have to pass through a lymph node to get returned to your tissue fluid eventually. So it's kind of like a border crossing of a $30 billion wall. And at that border crossing, where hopes and dreams are made, then you can just sit there and monitor there and have your white blood cells, and particularly your B and T cells, will sit there and monitor that area. And because they can go, yeah, you belong here, you belong here, you belong. I'm a foreigner. Okay, you're from Canada. Okay, so you can then take that and then you can fight that there, and that's how you can tell that there's a battle going on, is when your lymph nodes are swollen, because everybody's upset that somebody's trying to cross that border. Okay, now your functions, and this is where your notes start, I believe, up at the top. Your functions, so, is to absorb excess tissue fluid. Okay, so for sure it's going to pick that up, and that's a problem if it doesn't pick it up. Absorb excess tissue fluid. Is that number one? Collects excess tissue fluid at the capillaries. Number two, your lymphatic tissue will produce lymphocytes. Now, you have a big umbrella of white blood cells. But underneath that umbrella and of white blood cells, you already know what white blood cells do. What do they do? Protect, right. Underneath that umbrella of that, there are these special forces white blood cells, the Navy SEALs of the white blood cells, and those are lymphocytes. So your lymphatic system will produce those lymphocytes. and we'll talk more about them later. But then here's something people usually forget on a test or a quiz. Another function, your lymphatic system actually absorbs fat in your small intestines. Your small intestines, when we learn about our digestive system, there's folds on folds, and the tiniest folds of all are called microvilli. And why would you have a bunch of folds in your intestines? What does that increase?
Surface area.
Surface area for? Absorption. Yeah, you'll have more diffusion, but you'll have absorption of nutrients there. And in these tiny little microscopic folds, these microvilli, are these things called lacteals, and their job is to absorb the fat, convert it into lipoproteins, put it back in your circulatory system. So absorbing fat at the microvilli or villi of your intestines, I believe, collects fat at the villi, V-I-L-L-I, of the small intestines. So when you're picking up this excess tissue fluid, it's all, coming in, and there are lymph capillaries and lymph veins, lymph venules. If you get like a worm or something that blocks that, or if you have other issues, then you'll get backup of tissue fluid, and that causes swelling, and that's referred to as edema. Okay, so got some Kenkel action going here, and it's not like a blister that you can pop, like to release the pressure there. It's a little bit of extra fluid around every single cell, a little bit of extra fluid, and something is preventing that. But side note, if your toenails look like that, you should trim them, okay? And that could be very uncomfortable, but this one would probably be worse, okay? And so there's a slight swelling, okay, on her. Is that her left leg or her right leg? Left, okay? This is her knee, okay? So I would assume that would cause some discomfort. And so in that situation there, they might have to take some medicine or something. There could be a worm or something that's blocking that, and so you can't get, and again, this is not something like a big blister or something you can pop. It's just a little bit of extra fluid around every single cell. So that would be number 4, a problem called edema, E-D-E-M-A.
So what was number 2?
Protects the body by producing lymphocytes. Protects the body by producing lymphocytes. So problem edema, which is the accumulation of tissue fluid causing swelling. Are you now looking up pictures of edema to put in your group shared notes? Have you? Oh, apparently you are. There's some stuff you can't unsee. Yeah, problem edema, accumulation of tissue fluid causing swelling. All right, so the next part, are we good on 1, 2, 3, 4? Anybody need help with that? Okay, go to vessels. So we know we are in close association, the lymphatic system is in close association with the cardiovascular system. Close association with the cardiovascular system. And similar, we don't have a lymph heart. There are actually some organisms that have a lymph heart that pump the lymph around. We don't. We have lymph capillaries. And after we're out at capillaries, what comes back? Venules. So that's what goes next on your note. Lymph venules, and then lymph veins. And what do we know veins have to make things go in one direction? Valves. You can see the valves right here. And then it gets dropped off at the subclavian veins. Movement is the same as how we move fluid through our veins. The skeletal muscles will contract and push on the collapsible walls. So movement is dependent upon skeletal muscle contractions. Skeletal muscle contractions. And then number 4, once that tissue fluid enters lymphatic vessels, it is called lymph. It is called lymph. All right, so you have, when you look at your lymphatic system, you have your primary organs and then your secondary organs. Your primary lymphatic organs are your thymus and your bone marrow. Okay, inside your bone marrow, you have lymphoid stem cells, but you have other stem cells as well. So you don't say, you know, it's just, that's where those lymphoid stem cells are housed, is in the bone marrow. And that's, but your bone marrow is in charge of producing every single blood cell you have, okay? Your thymus gland, you can't see this on this gentleman right here because his thymus gland is gonna sit kind of above your heart, above your lungs a little bit right here. And your thymus gland is where, remember I said under the umbrella, you have lymphocytes, and they're called B and T cells. The T cells are born in the bone marrow, as are all blood cells. That's where they originate, but they mature, the T cells mature in the thymus gland, and that's why they're called T cells, because they mature in the thymus gland. It's kind of like the school where they go. And once they've all graduated and gone to school, which is right, you know, before you're born and as you're born, once they've done that, you don't need a thymus gland anymore. You teach self from non-self very early on. Before you're born and right when you're born, you're learning self from non-self. After that, you don't see the thymus gland because it starts to shrivel up. So you don't see it on him, but I will show it to you in a kid. Your secondary lymphatic organs, things like tonsils, are lymphoid tissue, you know, monitoring what's in your throat. Your lymph nodes, we already talked about, and your spleen. Your spleen is very similar to how your lymph nodes are monitoring your tissue fluid. Your spleen is going to monitor your blood. Yes?
If your tonsils monitor what's in your throat, how do you?
Well, the problem is sometimes you can get so many infections there, and I don't know what it is anymore, but when I was a kid, because I wanted my tonsils out, because when I get sick, it goes to my tonsils, and it swells so much, I'm like, you know, it's so painful, it's like you can't eat, it's terrible. And I wanted mine out, but I remember the insurance or whatever said, they don't like to take out your tonsils unless you get 5 major infections a year. So I remember them saying no. So if you try to keep them in, but if they are so infection prone that you're more likely to get some other sickness as a result of it, then they're becoming a liability and they're going to remove them. If people get tonsils out, it is usually as a child. Your tonsils are so vascularized. If you wait and do it as an adult, it can actually be life-threatening, believe it or not. Because people, when you get your tonsils removed, they will tell you you cannot do anything for 2 weeks. Literally, you need to lay in bed for 2 weeks or something like that if you're an adult, or like 10 days. Because if you jiggle around or do something and it tears, and I don't know what your diet is, I'm assuming it's all smoothies. If it tears, people have bled out through their tonsils. You know, like all this, because then what's going to happen is, if you've ever had your wisdom teeth out, I don't know if it happened to you, and I don't know if it was the anesthesia or something else, but after I got my wisdom teeth out, I remember, first of all, the thing I remember most is when I was coming out of the anesthesia, I wanted them to know that I was okay and they had done a good job, so I felt like, she just got her tonsils out, so we were talking about it. I felt like the only way I could really communicate that to them, because I had did I already tell you this story?
No.
I had all this gauze and stuff in my mouth, obviously. I was in high school and I'm getting them out, and I wanted them to know they'd done a good job. That would be important to me. I'm like that kind of a person who has to say, good job, or thank you, I appreciate it, or strangers, I have to tell them their hair looks nice, and anybody in the military, I have to thank them. It's part of a compulsion, I'm sure. So I can't like tell them, so I thought, I'll sing. I've got all this gauze in my mouth, you know, I'm coming out from under the anesthesia, and I'm singing, but I'm not getting feedback on it, so I need to sing a little louder. So I'm like, if that's how I thought I could tell them I'm okay, and they're like this, we can hear you, Winnie, it's good, it's good. And then I remember going home, and I can remember, we had a station wagon at the time, and my mom picked me up, and I'm driving, she's like, Winnie, are you okay? And I'm like, yeah, I'm fine. And then it was puking all along the side of the car. And then I remember, the other thing I remember is getting home and wanting to watch The Twilight Zone. It's this like creepy show, black and white. And I remember being able to say enough that I was going, Channel 5, Twilight Zone. And no, I would end up doing that. My mom's like, what's wrong with you? No. You know, so everybody has different reactions. Tell them what you did.
I just kept rapping in Hamilton. But I got out of apparently in the wheelchair, they had to roll me down the curb. And I went off the curb, but since I was in a wheelchair, he had to tilt me back. And I was like, wee!
You can have some fun times. Why are we talking about wisdom teeth? I don't know. Anyway, you could throw up, if you get blood. Oh, I know. I got it. I got the connection. I'm there. Sorry, super sorry. But when get your tonsils out, you don't want it to bleed down into your throat because it can make you sick. That's what can happen. And so if you jar your tonsils, now you're bleeding into your stomach. That can make you sick. And now you're throwing up. Guess what happens? More. And then it's hard for them to stop it because it's literally like vascularized patches that are just bleeding out in your throat. So they do not like to do it as an adult unless there are some serious infections going on in there. So I hope that answered your question. Okay, so here I'm showing you little eviscerated girl. So you can see, they need to show a girl so you can see the thymus gland. So it's sitting right here. So your thymus gland, T cells mature here. Your bone marrow, all blood cells are going to come from your bone marrow. Your B cells, though, mature in your bone marrow. That's why they're called B cells. And T cells mature in your thymus. And they fight differently. We'll learn about them. These are your two special forces guy. Here's a lymph node, and here's a spleen. So on your notes where it says organs primary, red bone marrow, all blood cells form from this tissue. All blood cells come from this tissue, and B cells mature here, and you have that. The thymus gland, T cells mature here. T cells mature here. Okay, so blood in general comes from your bone marrow. You wouldn't say that your bone marrow is your lymphatic system. It's just that's where the cells happen to come from. Here you have your myeloid and your lymphoid stem cells. These right here, blue is going to tell you, what do all of these guys do? Because at this point, you know what all these guys do. Go. Go, blue. You remember who blue is? Look at your chart. Okay, what did they say red blood cells do? Carry oxygen. What is inside of them that does that? Hemoglobin. How much do you have? 250 million molecules of hemoglobin for every red blood cell. How many oxygen molecules can a hemoglobin molecule carry? 4. Good. Okay. What are platelets' jobs? Blood clotting. Okay. These right here, granulocytes, they're called see how you can look inside? They have weird nuclei. Okay, first of all. Do you see how that looks like there's little granules in there? Hence the name granulocytes. They're underneath the umbrella of what? White blood cells. Okay, so what are these guys going to be doing? Fighting. Okay, good. Now, also from your blood can come the lymphoid stem cells, and this is what makes the B lymphocytes and the T lymphocytes. The natural killer cells, and I'm going to say it like that, you'll know because you're going to watch a video, and then that's the only way you'll be able to say it too. But anyway, the natural killer cells could have been full-on Navy SEAL T lymphocytes, but they just didn't go to the school of thymus. And since they didn't go to the school of thymus, they kind of pose like Navy SEALs, but they're not really. They just have a lot of good guns for killing. These right here, what makes these so special is they have a memory. And this is critical. This is why you get vaccinated. You can't afford to have polio over the weekend and drag around your right leg, okay? Because you are paralyzed due to the polio virus. You can't afford to do that. So you go and get a shot. When you get a shot, you're getting a weakened version. It has all the markers of polio, but it's like it's shooting blanks. It can't hurt you. So by getting that vaccine of polio, you're giving your body time to learn that disease, build clone armies. There's nothing really to fight after that. So then the armies all commit suicide. What do we call cellular suicide? Apoptosis. Apoptosis, good. And then you'll leave some cells behind that are called memory cells. The memory cells will patrol your body, and they react much faster and with a greater response the second time. So if you're ever actually exposed to polio, there won't be any waiting time. You'll immediately respond and immediately manage it. Because see, the first time you encounter something, the first time you encounter some pathogen, it takes about 10 days to 2 weeks to build clone armies in order to take care of it. Because you only have about 1 or 2 cells that can recognize that particular pathogen. And you have to find that cell and then get that cell to make clones of itself to fight it off. And that's why when you do get sick, probably like a cold, those of you who have had a cold or flu this season, it takes about 10 days to 2 weeks until you overcome it. Because you're going to build that clone army. You won't get sick from that same cold virus again this season. However, you could get another cold next year. Why is that?
It could mutate.
It could mutate. It's new, right? It's a different strain of that. And that's why when you get a flu shot, they're trying to guess what are going to be the pathogens that are out there, and make a little soup of that, of all the different ones that are out there, and give you a weakened version of that to adapt your body to be ready to go, to have a memory of it, so if you actually do get exposed to it, you respond much faster and don't end up getting sick. So we're going to talk about their role in a little bit. These guys fight, but it's like every time they see it, it's like they've never met. It's like 50 first dates. Oh, never met you before. Oh, never met you before. And so they respond that same way every single time. Okay, so here's a lymph node close up. Very close association with your cardiovascular system. Monitoring again to see if anything, any pathogen is there. If you go to secondary, go down to letter B, lymph nodes, it filters tissue fluid. Filters tissue fluid. I haven't gone over that yet. Yeah, filters tissue fluid. Okay, and now here, your spleen. Okay? Now, this particular picture of a spleen, and note, when I make these things, I spend hours literally looking for the pictures that I'm going to put in here. You know where I got this picture of a spleen? From a cooking website. You can't cook human spleen? What's wrong with you? No. They would advertise human spleen. Good Lord. Okay. Anyway, this is, I don't know if it's like cow spleen. I don't remember which kind of organism it was. But anyway, you could cook a spleen, not a human one. Apparently that would be illegal. It's called murder. But anyway, your spleen does for your blood what lymph nodes do for your tissue fluid. It's monitoring your blood to see if there are any pathogens in it. And so you can have white blood cells hang out in your spleen as well. So for spleen, little letter A, put filters blood. Filters blood. And then here's some tonsils. Look a little inflamed to me. But these tonsils trap germs in the throat. Traps germs in the throat. Now you have some other ones I'm not mentioning right here. They're called Peyer's patches. There are things in your intestinal walls that are monitoring. So there's more things out there always monitoring what's going through your body. Okay? Not it. Not it. Whoever's not it, pass or play, tell them 3 major content items you learn. Go. 3.
So it's like there are lymph capillaries, then venules, then the lymph veins, and then some plasma veins. Like I didn't know it was just all veins. I just vessels. And I also learned that the difference between B and T cells is just
Okay, and just be yourself. Thank you, my dear.
Of course.
talking about this.
Maggie, I have everything but the squirt bottle.
I have the squirt bottle. Okay, Swedish. Thank you. Ah. Check with your bio buddy, considering we just finished talking about the spleen and lymph nodes in the thymus gland. Can you see if they need a little shame bell rung for them this morning, a little shame bell, or is it a gong of victory? Oh, I like that gong. That was our through the phospholipid bilayer. Yeah. But I like that's a better gong. Gong or wing or smiley pile of face. Which is gross. Here, let me give it back. Let me give it back. Focus on the task, Stephen. Kai, Josh, Carolyn, Mia. Oh, Trixie, Bo Trixie. Talk about it. What? What's going on? It is not the job of the lymphatic system to produce red blood cells. Take a look right here. Let's go back here. Okay, you have blood stem cells, and these will differentiate into lymphoid, lymphatic, here. Okay, and myeloid stem cell, and their job is going to be red blood cells. However, it is the job of the lymphatic system. If you look at task on your notes, look at task 3 under basics. See it? Collect fat at the villi of the small intestines, transports lipids, fats, right? Absorbed from the digestive system. So that is their job. So note that because a bunch of you missed that one. That was a tricky one. Not Lily, but a bunch of people did miss that. Not Austin. Good?
Should we type it?
I've already said cell, so you just need to give me the.
Just the one letter?
Yeah.
Wait, just the letter or the capital?
Well, it is only called by a letter. Did I present it as a capital?
Yes, you did.
Okay then. Oh, good. You all got it right. Just different ways of saying it.
Oh, we're Stephen first.
Yeah, I put in all the possibilities in case you did the other one. So good job. Tell your bio buddy. Yes, Stephen, good job. Boom. Oh, that's the one. Damn it, Rustin. Yay! Swedish. Good job. All right. So now let's start talking about the process of this defense mechanism. So our first defense mechanism is just keeping things out of our bodies. So what are some things we have to keep things out of our bodies? Yes?
Our skin.
Our skin. Perfect. Okay. So these are very non-specific defenses. Okay. Things like skin. Our skin's really important to us. Think about how your skin is flexible. In order to keep it flexible, we secrete what? Oil. So oil keeps it flexible because if it dries, what could it do? It could crack and then things could get in. Okay, so, and even the oil is helpful to protect against bacteria. And then we also have what? Hairs, those are also helpful. Okay, so here's a nostril, something in it. Okay, your saliva in your mouth has antimicrobial agents in it, your saliva. It has things like salivary amylase, which helps digest starch, but there are antimicrobial things in it as well. That's why you might see a mom, if there's nothing to wipe pacifier with, she put it in her mouth before she gives it back to the baby. There's antimicrobial agents in it. A dog has even more antimicrobial agents in their saliva than a mom would, than a person would. But you don't give it to the dog to lick because they lick their butts, right? So, but you do have, that's a very protective response. Your stomach. Do you think your stomach has a high pH or a low pH?
High pH.
Low.
Super low, yeah. That's why when you throw up, it kind of in your mouth. And the reason why you have a low pH is to activate an enzyme, pepsin, so it can digest proteins. But that low pH helps to kill off things as well, okay, in your stomach. So, oh my gosh, that's my hairdresser, Summer. I do not know why notifications come up on Facebook, but there you go. So go to, it doesn't even come up on my phone. So can you tell me how I don't get it on my phone, but I do get it on my smartboard?
You can turn your computer on.
No, I have something from Twitter and from the tech office. No, I'm not. Okay, so go to barriers to entry. Oh wait, it did just come up on my phone now.
Yeah, so it's like a delay.
Yeah, weirdest. Okay, so go to barriers to entry. Number 1, skin and hair. Oil glands inhibit growth of bacteria. Ciliated cells line the respiratory tract. You have that. Stomach with a low pH. And then you have harmless bacteria that take up spaces in our intestines and the vajayjay, preventing pathogens from colonizing. Preventing pathogens from colonizing. They occupy real estate so that bad ones can't. All right. So then how does your body know who the invaders are? How does it know what to be concerned about and what to ignore? Well, the way you learn that is that every cell, literally every cell in your body as well, you have surface markers. Do you remember when we talked about the different blood types? When we did our genetics? What were the different types of blood? A, B, A, and O. A blood has A surface markers on it, A antigens. B blood has B, AB has A and B, 2 different ones, and then O has none. And the RH was the positive negative, right? That's a surface, a cell membrane surface marker. Antigens, they're referred to, surface markers, they're referred to as antigens if it will trigger an immune response. My blood in me is not going to trigger an immune response because it belongs to me. But if I gave it to somebody else who had a different blood type, could it cause an immune response?
Yes.
Then it would be referred to as an antigen. Okay, but all of your cells have surface markers. Bacteria have surface markers, and viruses have surface markers. And the problem is some proteins or even little carbohydrate side chains from things like peanut butter or pollen, our immune system interprets them as what? Antigens. And starts to trigger a whole immune response to that. Yes?
So is that why with the organ donors you have to have a certain blood type?
Yes.
And is that the only factor that goes into preventing it from having an
Yeah.
infection?
They're just trying to prevent an immune response to it. And it's not just blood type. Like blood type you have, we talked about HBio, right? And we talked about positive and negative, but there are even other antigens that show up on the surfaces. And so they have to match all of those as well. And that's why you're more likely within your family to get like a kidney is with somebody within your family, because you would have similar antigens. And so you wouldn't consider it an antigen. So what do you do when something like this comes in your body? You call the North Koreans, okay? And so you call in fighters. So let's look at the different types of fighters, okay? So you have your general police force. And how many of you, I have policemen in my family. Any of you have policemen in your family? Okay, I love policemen, so don't, I'm not putting policemen down, but they're your general fighters, okay? Then over here, these are your special forces guys. Do you see what I have right here? I have T cells, remember these guys? Where do T cells mature? Thymus. B cells mature in your bone marrow. Then these guys, natural killer cells. Remember, they could have been T cells, but they didn't go to the school of thymus. And so they do come from those lymphoid stem cells. But they really are part of your general, and by general police, I mean your innate response. Everybody is built with this innate immune response with the police force. Special forces, those have to be triggered and developed, learned. That's your memory one. We'll talk about that in just a little bit. So let's look at some of the players here in your special forces, the ones right here. And I'll break them down in just a little bit, but the most numerous one of all, okay, of all your white blood cells, the most numerous one of all, I think it's like 70% of all your white blood cells are the neutrophils. Okay, they're like the first on the scene when there's an issue. And basically, most of what your cells do when they get there is they just try to eat whatever the bad thing is. And they're just like, okay? And they're like, I will destroy it. Okay, and so that's what they do. And neutrophils are first, and they will get there quickly and try to handle it. If you look at, what am I looking for? Oh, right here, a macrophage. Macrophages start off as monocytes, smaller cells, and then when they get to wherever this little, immune system battle is taking place, this little infection, they actually get bigger, bigger, and bigger. They're kind of in for the long haul. They become these huge cells just trying to engulf everything. And they will engulf all the bacteria or pathogen until it actually kills them from overeating that pathogen. When you have dead white blood cells who have fought the good fight, that's called pus. So wherever you have pus, that's sign of an infection, because that's where they were working. And you can have acne where you have pus in that area, you have bacteria, but it could be something like, I knew somebody who had their appendix out, and when you have the appendix out, there's like some internal stitches and then, some internal stitches and then some other stitches, and anyway, it got infected in there. And his wife went, who I was related to, they went to the doctor, and not to totally gross you out, but they're like a little concerned, you have to clean that area. And the doctor went and pushed on it. It went just pus everywhere. And she goes, I literally thought I was going to pass out and die. Not only was it disgusting to actually view, but it also smelled hideous. And so they had to clean it all out and like re-stitch it. That's not a good sign, okay? And we'll talk about, that's part of what we'll talk about with our inflammatory response. So your police, these are first these come in, and then this is special forces, takes usually a little bit longer. Mast cells, some of you are familiar with. Mast cells secrete histamine, which trigger an allergic reaction and inflammation, and that's why some of you, when you're having an allergy attack, you'll take something like Benadryl, which is what? Antihistamine, and it counteracts what the mast cells are making. All right? So when you have an infection or something, then you can see this inflammation, this inflammatory response. So this guy, when I made this collage of infections, which there are some things again there that I cannot unsee, I read about some of them, and this guy was like hiking through a river, and he fell backwards, and there was broken glass on it, and just sliced up his hand right here. But you can see it, like you could get a bug bite or a spider bite, and you get all swollen up because that spider is putting a toxin in you that is causing that inflammatory. This guy has some kind of sty right here in his eye. Clearly there's something going on with these toes. Okay, so why do you have an inflammatory reaction? Number one, it's a result of damaged tissues or invaders. Damaged tissues or invaders. And the fighters who comes on the scene when you have these, we'll go through a few of them. Thank you, thank you, thank you. Josh, immediately. I told you to stop selling crack. Okay, so let's look at some of the fighters that you have. Those granulocytes, okay? They are usually first on the scene. Neutrophils are the most numerous, and they like to basically eat the bad guys. So on your notes, go to neutrophils. Most numerous, first on the scene. They're big time eaters. Second one are macrophages. They start off as monocytes, a smaller one. They're slower to the scene, but big time eaters. They live longer, and they alert the other parts of the immune system. And then third, you have dendritic cells. That comes from the word detritus or detritus, like the dead stuff. And they are like macrophages. They like to eat too, but they alert the rest of the immune system, and they're kind of like the garbage men. They go around and clean up all the dead tissues. Cells, dead cells. And so then here, just to show you a white blood cell functioning here, you can see he's literally chasing bacteria around, trying to catch it. Those are red blood cells that you see in the background. And got it. Okay, and then they'll literally digest that bacteria. Okay? Right. Here we go. All right. So we got good. Now, if you see in your notes, I put APC. Those are antigen presenting cells. When these macrophages and these dendritic cells, when they eat the bad guys, they literally present it out, and it's kind of like a trophy to them. They're like, look what I ate, and they present it on their surface, and they do that in order to elicit support so that they can find the B or T cell that can recognize it. We'll learn about that a little bit later, but that's what I wanted. I just put it in these notes. It will make a little bit more sense to you once we finish all of the notes, but I wanted to note it here. They like to present what they have eaten. So when you have an inflammatory reaction, let's say you fall and skin your knee. So you're skinning your knee. These are bacteria coming in. Here come blood platelets. What are they doing? Yeah, they're trying to clot. And then this mast cell right here, okay, part of your policeman, he's secreting histamine, okay, a chemical which is affecting this capillary right here. And this is how it impacts it. Histamine will take this blood vessel, and remember, capillaries are one cell thick, and it'll take the spaces and make it bigger between each of these cells. So when the blood comes in, that hydrostatic pressure, it forces even more out. And now think about this. Now you have more fluid out there. That's going to cause that area to what? Swell. The blood is warm, so it starts to get hotter, maybe killing off that bacteria. And by creating that space, it enables something like a monocyte to squeeze out between the walls and get out there and fight that infection. So mast cells dilate our blood vessels to facilitate your fighters to get there on the scene and do their job. And this is why, if you are allergic to something like pollen, okay, or cat hair, your nose is running and drippy and all of that, because all of your blood vessels have been dilated, and by taking something like Benadryl, it shuts that back down, and the histamine doesn't it counteracts that histamine. So mast cells are secreting histamine, and then here you can see coming out, squeezing between those is a neutrophil, most common. He's eating a bunch of bacteria. This macrophage, he started off as a monocyte, he'll get bigger and bigger. He's eating as well, and he's releasing chemical signals, kind of like pulling a fire alarm, and it's going, alarm, alarm, we've got stuff, come over here and fight this bacteria at this wound. That's what those chemicals are doing. Yes?
So if you hurt your ankle and it starts swelling, is that from like blood coming out of your ankle?
Yeah, that damaged tissue from that soft tissue damage, that can trigger this inflammatory response. And what do they tell you? Put it on ice. You see why? Yeah, exactly. Okay, so these are the steps in the inflammatory response. And when you get that, that means you have an injury or you have an invader, and your body is trying to facilitate them to protect that area. So go to where it says symptoms and causes. You get swelling because mast cells release, what was that chemical I said they released? Histamine, which causes vasodilation. Redness, higher temperature, you have enlarged capillaries. Enlarged capillaries. And then because you have that swelling in that area, it pushes, everything's kind of crowded now, it pushes on free nerve endings, and that causes what? Pushing on your nerves, it can cause pain. Yeah. So swollen area triggering free nerve endings, and that's why you have pain. The results in a fever, that heat, you can have localized increased temperature in that area, a fever which inhibits growth of microorganisms. And then pus is just dead phagocytic white blood cells. Dead phagocytic white blood cells. And then leaky dilated capillaries allows fighting cells like dendrites and neutrophils and other white blood cells to more easily access the injury site. More easily access the injury site. Okay, then you just have a couple other items to know that's part of your innate, what you're born with immune response. And one of those are, you have these, you can have signals that are released, chemical signals, but you have other complement proteins which will go to a bacterial cell and they build, it's a very complicated process, but these proteins work together to basically drill a hole into the bacterial wall, and the inside of the cell is hypertonic, the outside is hypo. So now they have a way to get in, the fluid goes in and causes the bacterial cells to burst and die. So it's a very complicated process, drilling these holes, fluid goes in and it causes it to burst the cell. And then you have natural killer cells who go up literally to that target cell, and it's like they dock with it and throw a bomb in it and kill it. And I'm going to show you a short clip of that. But on your notes, go to where it says protective proteins. Complement proteins amplify response. and drill holes into the bacterial cell walls. Amplify response and drill holes into the bacterial cell walls. Chemical, and you have chemical communication to warn invaders and motivate killing. To warn invaders and motivate killing. And later in the notes, I'm going to come back and tell you more about those, but I just need you to know that much for now. And then natural killer cells, they kill virus-infected cells and tumor cells. Natural killer cells kill virus-infected cells and tumor cells. They are not specific. They have no memory. And they release protective proteins that stimulate B and T cells. Let's watch that.
Of all the immune system soldiers, natural killer cells are the most aggressive. They are lymphocytes with no immunological memory and are part of your innate immune system. Natural killer cells make up about 5 to 15% of the total circulating lymphocyte population. Natural killer cells are called natural killers because they do not need to recognize a specific antigen before releasing their toxins and destroying a viral infected cell or cancer cell. They target tumor cells and protect against a wide variety of infectious microbes. In several immunodeficiency diseases, including AIDS, natural killer cell function is abnormal, thus allowing the viruses to multiply inside of human cells. Natural killer cells kill on contact. The killer cell binds to its target, aims its weapons, and then delivers a lethal burst of toxins that produces holes in the target cell's membrane and creates events that destroy the cancer cell membrane and cleaves DNA into many pieces in a programmed cell death, that is, apoptosis manner. After releasing its lethal package of chemicals, the natural killer cell can detach from the cancer cell and kill many other circulating abnormal cells. Indeed, research has shown that most of the tumor cells that enter the circulation are destroyed during the first 24 hours, and only a few cells succeed in establishing themselves in distant organs from the primary tumor, which is called metastasis. Natural killer cells may also contribute to immunoregulation by secreting high levels of influential lymphokines. Therefore, research to develop natural products to stimulate the natural killer cell activity, especially in immune-suppressed patients undergoing chemotherapy for cancer, or in any viral disease such as AIDS or bird flu, where immune suppression occurs, is very important in the regulation of aspects of the immune system which affects our overall health. Finally, we come back to the beginning of our knowledge of a natural killer cell. Here lies a natural killer cell in a lawn of sheep red blood cells. These cells are perfect targets for the natural killer cell, possessing no MHC1 receptor. The wrath of natural killer cell is fully vented on the surrounding sheep red blood cells. The cytotoxins completely destroy the sheep red blood cells, leaving clear plaques around the natural killer cell. There is no apoptosis event, just direct cytotoxicity. The natural killer cell is one of the key soldiers in the fight against viral and cancer growth.
Okay, and that is all your innate immune response. But here's the deal. Having all of that will not wipe out the virus or bacteria. You need to enlist your specific immune response, and we will start there next time. I want to give you time to touch base with your lab partners and see where you are on your lab, okay? And then I will talk with you next time.